allow us to do is this. What's that? 4. Okay, good. Okay. What's that? 8. Okay. Logs allow us to do this. 2 to what power is 6? Oh. Yeah. That's where logarithms come into play. Okay. Logarithms will be ways to help us work with what are called bases and exponents. Okay. As we go through these things, there's a bunch of different little properties and a couple of different rules and things. But for the most part, it's very generic. Basically, it's this. Log base b of y is x. That's how you say that. The base is what we call a subscript. It's lower than the log. And it means the same thing as b to the x is y. This is log form. This is exponential form. We've generally worked with exponential form. 2 cubed was 8. 2 squared was 4, and so on and so on. What we were looking at there is when I said 2 to what power was 6, that's an exponential form. But in terms of a logarithmic form, it would look like this. Our base in this case is what? 2, because it has the exponent. The base has the exponent. So it would have been log base 2 of 6 is x. Logarithms allow you to solve for that. In your calculators, obviously we might as well do this real quick, there are buttons for logs. There's one button that actually just says the word log, and then there's the other buttons. The one that says log is right here next to the 7. That's what we call common log. Okay. The log that has no base written, which is what you see here, actually has a base to it. It's called base 10. We just don't write it because it's common. Okay. Whereas the other one, so let me write this out here. So we have log. Just that one is what we call the common log. Oops. And it's technically a base 10. We just don't write the 10. It's like not putting a 1 in front of a coefficient. It doesn't do it. That's that with that goes on. In order for us to do the one where it says log base 2 of 6, we have to press different buttons. So on your calculator, and we'll be doing a lot of log stuff, not so much today as far as the calculator is concerned, but as we go forward and we solve equations later on this week, we got to know where these are at. Alpha, window, 5. An option says log base. If you select 5, you'll notice that it now blinks for a base. That's where you would put your base in. Okay. So the example we were just talking about was that log base 2 of 6. We just put a 2 there for log base 2. And then we hit the arrow over and put in the 6. So so you get this crummy decimal. So if I raise 2 to that crummy decimal, it should equal what? 6. So the idea here is if I go 2 to that answer, I get 6. That's how that works. Logarithms are ways of solving for exponents. Right? That's where they come from. I know they're used in chem. I think in AP Chem more so than regular. You guys get into that stuff. Because I remember one day my wife came home from school. She was just complaining that, why the hell do we have to do these logarithms? Because she had to do an AP Chem. She's like, I forgot what that meant. I'm like, well, I can explain it. She's like, I don't want to hear it. She was just mad. Math. Anyway, does that make sense where that comes from? Sure. It's just a way to solving it out, okay? It's just a way of solving them through. So for right now, what I want us to think of is how we say it. Log base b of y equals x, b to the x equals y. Always think of it as Your answer, this base and this base will always be the same. It's just how the exponent works. Okay. So what we do is, they have two main properties. There's two main properties of logs, and these come back into play when we do our graphing. So let's see here, we have log base b of y equals x, and b to the x equals y. Remember that these two guys are equivalent. The two properties are these. Log base b of 1 is 0. That base b, it can be any base. It can be log base 6 of 1. That just means 6 to the 0 is 1. Because this implies b to the 0. And that's where that comes from. Same deal with, let's see it. Same deal when you have same bases. Log base b of b, excuse me, is 1 because anything to the first power is itself. Those are the two main properties that we deal with logs. Those will be the two main properties we deal with when we start graphing. As you can see, we'll be substituting in values for zeros and ones as we go through it. So logs, when we graph them tomorrow, they will have some of the same properties as exponents, but as you'll notice, when you flip-flop the x's and y's, they're kind of inverses of one another. We'll get to it. All right. So what these can allow us to do, we'll have some very simple, what's called logarithmic form, exponential form, and how do you rewrite between the two ways. Remember, think of it this way. It says log base 2 of 32 is 5. That means 2 to the 5th power is 32. Remember these, that's how these things work. Log base b of y is x, b to the x is y. Those two guys flip with each other. Right? That's how the exponents move. So if you wrote this in terms of exponential form, this just means 2 to the 5th power is 32. Our bases are always going to be positive, so you don't have to worry about that. Exponents can still be negative, that's okay. That still goes through. What would the next one look like? Either 5 to the 0 is 1. Yeah, anything to the 0 power is always 1. So 5 to the 0 is 1. Right. That's what else is 10. What's that?
The next one, 10 to the first is 10.
Correct. The next one, again, they put the 10 there. Sometimes they will, sometimes they won't. In this case, they did, just so you remember it. So that's your common log. So 10 to the first power is 10. And that goes off the property of, excuse me, anything to the first power is itself. Decimals. Change to a fraction. What is 0.1 as a fraction?
1/10.
1/10. So now when you see this as 1/10, so log base 10 of 1/10 is negative 1. Do you see how that works now? As 10 to the negative 1 is 10. It's easier to see it as fractions as opposed to decimals. So 10 to the negative 1. All those properties of exponents still hold true. How your fractional values work, how you can flip them with the negatives, and all that. Right? And then lastly, it's log base 1/2. They use slashy fractions sometimes with these things just because it's easier to type than the over-under ones. This just stands for, again, 1/2 to the negative 1 is 2. Remember, you're using the exponent rules. Negative powers flip things. We'll go from there. Excuse me. And it goes back and forth from just rewriting from log base exponential form. It's straightforward. What direction what do logs come from? Trees. What directions do trees grow? And what kind of exponents are they going to have, you think? We'll get there. Same idea. Do I need to go through all these? No. Solving. This is where it comes into how we're going to solve these things without using calculators. The stuff that we do today is going to be a lot of rewrites and a lot of simplifying. So in this case here, we're trying to figure out log base 9 of what is a half. What do you mean by?
Like you put 9 to the 1 power.
Okay, then what does it equal?
X.
Okay, what does it equal? You're right. You're right, it's 9 to the half, which is what? What's half power again? Good, so what is it?
Oh yeah, great.
You're right. That's okay. That's okay. And that's what that looks like. Uh-oh. Okay. You're a little... All right. Remember, we flip-flop back and forth within the properties to make things work, and they work rather quickly. Okay. Again, this goes into simplifying. Lots of simplifying. When you're asking yourself here, it says log base 3 of 81. What you should be asking yourself here is 3 to what power is 81? 3 to the 4th. Very good. So this simplifies then to equaling 4. Okay. I'm going to skip this one for right now. I'm going to come back to it. This says 1/2 to what power is 8. Now, when you have a base that's a fraction and a value that equals something, that means your exponent had to do what?
Negative.
Had to be negative. Very good. So you know it had to be a negative. So 2 to what power is 8? 3. So this would have to be negative 3. Okay. Go back to that log base 5. What is that as a fraction? 0.04. 4/100ths. Okay, so that's the same thing as log base 5 of 4/100ths. 4/100ths is how much? 1/25. And that's why we write things in terms of fractions, because now 5 to what power is 1/25? -2, very good. Yep. So this equals -2. All right. Whenever you're switching between the whole number to fraction or fraction to whole number, the exponent had to be negative in order to make that flip. Okay? It has to be a negative to make sure that make it flip. And then it's just a matter of 5 to what power is 25. Okay. And then lastly, we just did this one, log base 9 of 3. Log base 9 of 3. 1/2, very good. Remember, it means 9 to what power is 3. So it's the 1/2 power. Okay. So glad you're not dead. Welcome back. I forgot to say that.
Yeah.
Did you have a good trip? I wasn't. It was sad. It was cold. Nice up yesterday. So we were outside with the kids. We're playing basketball. No wonder why I'm like this now. Anyway, we're not doing that one. Inverses. Now, this is where it can get a little messy. Again, it's not going to be terribly difficult to work with, but there's a few things that happen. Now, when you're dealing with inverses, remember, by definition, you substitute in one for the other to make it work. So if we have our two functions, if I take this in for x to start with, I would get log base b of b to the x. To show that these guys are inverses, they'd substitute in for one another, you'd have to simplify it out to equaling x. In this case, these two bases, since those two bases are the same, they undo each other. Yeah, they basically cancel each other out. We'll think of it that way. That's how you're left with just an x. The reason that we use this stuff is because eventually we'll have a problem that'll look like this, where it'll say log, excuse me, base 2 of 8 to the x, and I want to simplify that. Well, how do I rewrite base log? How do I rewrite 8 as a base 2? Basically, I'm asking 8 is 2 to what power? 3. 2 2 cubed is 8. Yes. So this is the same thing as saying the log base 2 of 2 to the 3x. Are those bases the same?
Yes.
So what drops? These are the same, so you just get 3x. Eventually, this is what's going to allow us to solve equations by doing the same thing to both sides. I can log both sides of an equation. And then another one we'll do is called exponentiate. I'll show you an example of that here in a second. So that's why this one works going that way. And then if I go the other direction, if I say it's b to the log b, again, since these two guys are the same, even though the log becomes an exponent, if those bases are the same, the value of x just remains. They undo one another. You'll hear this term that we use, it's called exponentiate, and I'll show you, like I said, I'll show you an example how it'll work when we do an actual inverse of something here in a minute, okay? It sounds really weird, but it's literally just moving stuff around. It's undoing. It's like, how do you undo multiply, you divide? How do you undo add, you subtract? How do you undo logging, you exponentiate? That kind of stuff. It's just another way of doing it. So what will happen then is we can use these properties to simplify. And like I said, this first one is pretty straightforward. It's 10 to the log of 2. Well, what's the log base of what's the base of the log? 10. And the reason that it's 10 is because you don't see anything. Since there's not a 10 here, that means it's implied that it is your common log. Are those two bases the same? Yeah. So it just drops and you get 2. All right, that's where that comes from. The next one, you've got 3 and a 9. 9 is not in base 3 right now. How do you rewrite a 9 to have the base 3? Yeah. So you get 3 squared. So this can be rewritten as log base 3 to the 3 to the 2x, which undoes those bases get undone, and you're left with 2x. It's baby Ted gets wood. It's better than that. It's good.
Oh.
It's never going to stop now, is it?
I don't need to do these. These are boring. Oh wait, no, I'm sorry. Let's simplify. Let's try these. Log base 2 is 64.
Oh, this one.
Remember, you want to ask yourself, how do you get the 64 as a base 2?
Huh?
What's 2 to the 5th? 2 to the 6th, that is. So this is the same thing as saying log base 2 of 2 to the 6th. They undo one another, and you're left with 6. Okay. Excuse me. Now, this next one's a little bit weirder to think of. But can we think of it in terms of this way? 25 to what power is 5? 1/2. Okay, 25 to what power is 5? Again, you're looking at it, as you rewrite, think of it in terms of exponents. All right, so this is log base b of y is x, so b to the x is y, so this means 25 to what power gives you 5. So as you go through it, the numbers themselves will be workable. We know that a half power is a square root. That's where this comes into play. That's how we're going to do this. It's log base b of y. I was just rewriting the 2 forms here. Yep. Because you can remember they're equivalent to one another, how they write them through. Okay. Log base 6 of 1. 0, good, exactly. Anything to the 0 power is 1. So 6 to the 0 is 1. So this means this answer is 0.
If the base is 1, or if the base could be 1, doesn't that kind of break it? Because base 1 could be anything. or to the power of anything, it can still be 1.
Mm-hmm. Yeah.
Is it just not counted?
For with base 1? You can have base 1, but yeah, you're right. I don't think you'll ever see anything in a base 1, unless it's like a trick question that I throw hit. What's that?
Is that for a base 0?
No. Because base 0 won't get you anywhere. It'd be 0. No, it should be 0, I would imagine.
Yeah, but what would it look like?
0. I don't think you'll ever have it. I think your bases are always positive value. Cool. There will be no negative bases. Your bases can't be negative. Always be 0. What's up? What's the last one then? We just talked about, what's that? Yeah. Because when you're looking at your base, you're thinking of it as the base to what power gives you 5. So 25 to what power is 5. Remember, when you're saying log base b of y is x, it's the same thing saying as b to what power is y. So 25 to what power? It's counterintuitive to what we've learned. Yeah. That's why it takes a day or so to get going, because a lot of people make that mistake between half power and squaring. It's like, oh, it's 5 squared, but you got to remember that it's on the other side of the equation. Okay. Last one, it's 10 to the log of 4 gives you 4. Okay. We talked about the common log a minute ago, but we do want to talk about what's called natural log. Natural log comes from log base e. So log base e is the same thing as saying natural log. On your calculator, there's a button for it. It's next to number 4, and it says ln. It stands for log as of the natural base. Okay. We use e, obviously, because we did that with the PERT stuff, exponential growth, decay, that kind of stuff. So if it does wind up with its own thing, it has its own button to make itself work. Now, a lot of times what you'll see us do whenever we deal with what are called natural logs, we'll probably rewrite them as log base e. There's a reason for it, because it allows you to simplify things out a little bit cleaner. We'll show up here in a second. Okay? So, natural log, ln, stands for log base e. Okay? That's all that means. Again, we'll get to why we press these buttons and we do all that stuff as we get to equations and stuff. Bless you. For right now, it's just a matter of what does it stand for. Okay?
I did have a quick question. Are we going to solve a logarithm without knowing the powers themselves? So, like, base 4 is equal to 1.4.
Yeah.
We're going to go through the entire math about again.
Oh, yeah. We'll get to, that's a good question. We'll get to stuff that'll look like, what's up? I just made a sheet too.
Because I feel like I've heard about that before. It takes, or not takes, or it ends up being an entirely different version.
It can be, but if you know how to set it up, it's pretty straightforward. For example, if you think about what something like this looks like, it is a longer, gross-looking equation to start with. But think about your order of operations. What do you have to do first?
Take away the 2.
Take away the 2. Then what would you do?
Divide by 6.
Okay, so if you took away the 2 and divided by the 6, so that means you're at negative 81 over negative 6, correct? If you simplify that out, that gives you what? Divided by 3, that's 27 over 2. Are we okay with that? And then you have e to the 1.5x minus 8 equals some fraction. Well, e, to undo e, you'd have to natural log. That's how they're inverses of one another. So because this, to get this exponent out, I would have to log base e on this side. These bases are the same. This would drop, wouldn't it? So then I get log base e over here of that fraction equals 1.5x minus 8. So then I add 8 and divide it by 1.5. It's just a really crummy looking decimal, but it's just working backwards off the order of operations. Does that make sense?
Yes.
They're not, I mean, you're thinking it's going to take forever. They're not that bad. The ones that are bad are when you have to condense them or expand them with powers and stuff like that, which we'll get to. Those are fun ones.
What's the longest problem? As long as you want
There's some trig ones that can get pretty nasty. We're so close to trig. It's so great.
Trig is too hard.
No. What's the graph one? Oh, let me do an example of an inverse one. So to do an inverse, like we were saying earlier, how you flip flop x's and y's. Let me show you what happens if you do one with a natural log. Because the other ones are really easy. So if I want to do an inverse, sorry. If I want to do an inverse, let's say it's y equals the natural log of x plus 1. And I want to find the inverse. What was our rule when we found inverse? What was the first thing you did? What? Flip flop x and y?
Yes.
So if I'm going to do an inverse on this, first thing I'm going to do is switch x and y. And then what do you have to solve for? Y. Okay. You have to resolve the equation for y. Now, natural log is the same thing as what? Log base e. The reason why we rewrite this is this. So I have x equals the log base e of y plus 1. Now, in order to get rid of the log, to get this y plus 1 stuff by itself, this is where that term of what we call exponentiating comes into play. This has a base e here with a log. So you have to make this whole guy an exponent. In order to do that, we put an e here, we put an e there. That is now e to the x equals e to the log base e of the stuff. See that? Are these two bases the same? What happens to the stuff? It just drops. So you wind up then with e to the x equals y plus 1. And then lastly, to get y by itself, what do I have to do? Subtract 1. And that's an inverse. You flip-flop x and y and resolve. And that's where the idea of what we call exponentiating comes into play. So you're raising whatever that log is to the same base so they undo each other. And just keep it balanced on both sides. Okay? It looks really weird, but after you do a few of them, it goes by really quick. Super excited. Makes sense. Hold your enthusiasm, please. Please. No. All right. Same thing goes for. What do you have for lunch today? I had chili. We had chili yesterday.
Sounds good. I'll do that. I can't walk.
Yeah, that's really all I got. I don't want to get into the graph sheet today, so we're a little ahead in the first hour. So this is on page 490. And what I have, 16 through 34 evens. And then some simplifies and inverses from 48 to 64. Okay. Knock those out. Shouldn't be too tough to go through those. We'll go from there. Tomorrow we'll go through these. My guess is usually people have questions on some of the inverse ones, so just remember how your inverse stuff works. Just flip-flop x's and y's. But yeah, we'll do graphing tomorrow. And we'll probably be able to start a couple of the properties to go through a few of them without too much of a hassle. And it's going a little bit quicker than I thought, so it's fine. No big deal. Okay. Those of you guys that were gone on Thursday, I forget what happened.